friends. This is second video in the series of energy scenario. In yesterday's video, we have seen that what are the basic facts related to energy. Energy consumption of any country that shows economical, political and social growth. Electricity is most convenient form of energy and that is used, and all other form of energy are ultimately converted to electricity. We have also seen three basic classification methods for electricity production. These classification methods are primary and secondary energy, commercial, non-commercial energy, and renewable and non-renewable energy. So after having background created of energy, we are processing towards energy scenario. And in that list, in today's session, we will have understanding of what is coal, what is Indian coal scenario and how it is comparable with the global coal consumption. Then we will also look at what is coal grading, how coal is being classified based on different categories. So just to have the idea of coal consumption, in a previous slide we have seen that almost 65% of power which we are using, that is coming through the source, that is coal. So obviously our coal consumption is very high. If you look at the world map of coal consumption, then China is the first country to produce the coal. Almost 46% of world consumption is contributed to China. Next comes India, which is almost 10%. And then rest of the countries have coal consumption by less than 10%. If we look for last 10 years of coal consumption of these different countries, it is like this. India in 2007, our coal consumption was 478 million tons, which has almost doubled and now it is 716 in 2018. If you look at this growth, similar growth is not so with the other countries. If you look at China, coal consumption, it was 2500 around million tons, which has increased to 3530 million ton. And in other countries, say for example in developed countries like US, coal consumption has reduced. So our dependency on coal is too high, hence we are having a higher consumption by coal. Compared to that, other countries have developed another sources as well as another renewable as well as non-renewable sources. So that dependency on coal is gradually decreases or remaining stable, while compared to that, we are on the growth map of increasing coal consumption. If we make a list of coal based on type of coal, it is like this: anthracite and bituminous and subbituminous and lignite coal composition. Based on that, different countries' contribution is shown in this table. So here is a world map which is showing consumption of coal. Darker the color, more is a coal consumption. So China being largest consumer, then comes the second, that is India, and here there is a summary listed also. If we talk about coal reserve in India, it is majority in this eastern region of the countries, of the states, Jharkhand, Odisha, Chhattisgarh and West Bengal. These four are the major states having major coal compositions available. Again, out of this coal, total available coal, just 21% of the coal is mineable coal, because if you look at the coal cost and coal excavation cost or coal mining cost, it is not a case that total amount of coal can be taken out from the earth layers. So comparing the cost of coal, only 21% of coal available in India is such that we can take it out at the present cost of taking out the coal. So if you look at the total availability, it is distributed in these states accordingly. And on the Indian map, this coal availability is shown. Dark color indicates more availability. Coal is being graded into different varieties, and that is basically grading is done by three methods: based on gross calorific value, based on ash content, and based on ash and moisture content. So if the coal is non-coking, if the coal is coking or if the coal is semi-coking, then based on that coal distribution or gradation is done. Where over here coking coal means when we burn the coal in absence of air, then in that case there should not be any residue form, then we can call it non-coking coal. If residual forms, it is coking coal, and if it partially forming, it is called semi-coking coal. So if we look at grading of coking coal, as mentioned, for coking coal it is based on ash content. So based on ash content, grade 1 to 6 is given. So when the ash content is more than 15%, it is steel grade, and when it is percentage keeps on increasing, grade number also increases. 6 grade coal has more than 42% and up to 49% of ash content. When we are talking of semi-coking coal, that grading is based on ash plus moisture content, and that categorization is shown over here. If you talk about non-coking coal, then they are being graded from G1 to G17, and this grading is based on gross calorific value. When we burn a fuel, amount of heat released by it, that is called calorific value. And if we consider moisture in the coal, then it is called gross calorific value. So when we have a highest grade of coal, which is used in a power plant, which is operating in a supercritical type of boilers, so that category of coal which has got as high as GCD of 7000 kilocal per kg, and that is termed as G1. From that to lowest grade of coal, which is G17, which has got just 2200 kilojoule per kg. It's a range of 220 to 2500 kilocal per kg. If we look at any power plant balance, it is like this. It is given for 1000 megawatt power generation. So say for example, this power plant which is producing 1000 megawatt, out of that available power to the grid will be 920, because to run the power plant there are certain auxiliaries. There will be pumps, motor, fans, blowers, and many other accessories which requires electricity. So out of 1000 megawatt power generated, 920 will be going to grid, and 80 watt is going back, 80 megawatt is going back to the plant to run different accessories. To run this power plant, if it is coal based, then it requires almost 12,000 ton of coal per day, and if it is oil based, then it will require 101 meter cubic meter of oil per day. In either case, water requirement will be 98,000 meter cube per day. And when we burn this much of fuel, suppose it is coal based, then it will produce 30,000 ton of carbon dioxide a day, as well as amount of sulfur dioxide and nitrogen dioxide added to the environment is around 680 ton per day. So when we run a 1000 megawatt power plant whose initial cost as of now is approximately 5000 crores, it will require this much of fuel and it will have this much of approximate environmental impact. When we go towards reservation or amount of fuel reserved for any country, that is identified by one common term which is known as R by P ratio, or it is reserve by production ratio. It indicates that how much reserve remaining at the end of the year if we divide it by the production performed in that year, and the result is the length of time the remaining reserve would last if production were to continue at the same rate. So say for example, if we have a total reserve available and then we divide by per year coal production, then that ratio will tell us that that is R by P ratio. So India's oil and gas R by P ratio is like this. For oil it is 17.5, and for oil it is for gas it is 40.2 years. While compared to that, our coal availability is strong, and which is around 100 years. So before going for oil and natural gas statistics, we should know that how oil and natural gas created in the earth layer. It is assumed that whenever in an ocean any plants or any sea animals, they die and then those get buried in the layer of earth, gradually there will be layer of soil, sand and silt will be deposited. There will be huge water pressure acting on it, and due to it, this buried plants and buried animals, they will gradually turn into oil. So whenever we are excavating oil, it is beneath that layer and that is stored oil. So as shown in this diagram, this is a trapped oil and this trapped oil is below the ocean, in the bottom of the ocean, and from that it is taken out. If we talk about oil proven reserve of different countries, it is like this. The ranking is given based on availability. So Venezuela is the largest source of oil, then comes Saudi Arabia and other countries. So if we compare US OPEC countries, that is Organization of Petrol Exporting Countries, then British Petroleum, and then their R by P ratios, it is given like this. Highest is there for Venezuela, that is 362 years. Then comes Saudi Arabia, 78 years. Iran comes 145 years. And likewise, it is given for all the countries based on their reserve and production rate. For that, one barrel is considered as 160 liters approximately. Again, if we calculate on world map different countries who are consuming oil, then we stand almost fourth. Ahead of us there is US, European countries, China, and then comes us. And our billion barrel consumption per day is like this. These are the data for 2018. If we talk of oil reserve, then oil reserve in different states is given in this table. Arunachal Pradesh, Andhra Pradesh, Assam and other countries are being shown over here. Other states are being shown over here. Our western offshore is largest contributor to the oil and next comes Assam. This two location has largest amount of oil reserve in India. If we, as we know that our production capacity is very less, hence we have to rely on the export and on import, and those statistics are shown over here. India is third largest crude oil importer, and we spend roughly 8.81 lakh crore per year to import this, and we are importing from these countries. So different countries have different import bills and that has been shown over here.